talk about what is called basic integration rules. So we're not really changing a whole lot today, but notice we've moved out of a chapter that we did last year. Okay, so we're now in chapter 8. We do chapter 8. We'll be done with this hopefully well before the end of this triad, and then we start chapter 9. Chapter 9 takes us a while to get through. Okay, usually I try to get through the bulk of it before Christmas, and then finish it when we get back from Christmas. So, all right. It's a massive chapter. So there's like 10 sections in chapter 9. So, yeah. All right. So when do we apply integration with inverse trig functions, and when do we use other techniques? So today is just basically about looking at different types, or looking at integration problems and seeing if we can apply the correct technique to them. Okay. I will show you a few different things. And ways that you've got to start thinking about it. Okay, so let's start with example 1 here. And you're going to see I'm going to purposely do some that look very, very similar to each other, but there's one little tiny thing that switches it from one type to another type. Okay, so when I see a rational like that, the first thing I'm going to do is I'm going to look at and see if it fits one of the inverse trig patterns. So look at your inverse trig pattern. Okay. In fact, let's rewrite this. Let's put the 4 out in front. 1 over x squared plus 9 dx. Now look at your inverse trig. Which one does it look like? There's 3 of them there. Everybody should have it up on your screen. It looks most like arctangent, right? This is kind of reversed order, right? If we wanted to, could we rewrite it as, instead of writing 9, I could rewrite it as 3 squared, right? And we did do a little bit of inverse trig last year. 3 squared, and it was x squared. So now it exactly fits that arctangent pattern, okay? So to integrate it, I keep the 4, okay? Then it says we've got to have 1 over a. What's the a value? 3. And then it says arctangent. Okay. The u value, so this is the a value, that's the u value. So what's my u value? X. Not x squared, just x. Because look at the formula. It says it's u squared. So the u value is just the x. All right. And then over the a, what's the a again? 3 plus c. The only thing you could possibly do to simplify that is multiply 4/3 arctangent of x over 3 plus c. So both of these are good answers. So you need to make sure before we hit this next test, you have your arcs memorized. Okay? They need to get done. All right, you're going to see them. You're going to see these ones on the AP test this year. Last year you could get away with not knowing them. This year you got to know them. Okay? All right. What was the big difference between this one and the last one? I added an x, so that totally pulls it out of it being an arctangent. Okay? So when I see something like that where I've got that x in the numerator, now I'm going to try to do a U-substitution. Okay? So I'm going to use the denominator as my u. So what's du going to be?
X squared. No, it's x. 2x.
2x dx. I have the x, right? Ooh, do I have the 2? Let's rewrite that. Isn't that the same as saying 2x over x squared plus 9? I just took the 4 apart, right? So do I have the 2x? Yeah, so I don't have to. I'm just going to use the straight u sub here. So I'm going to put what in for the x squared plus 9? U. For the 2x dx, I'm putting in du. All right, I'm keeping the 2 in front. When I integrate 1 over u, what do we get? Absolute value of u. What are we going to write down instead of u?
X squared plus u.
Good. Plus c. All right. You good with that one? Okay. What did I change this time?
X squared.
The x squared. Okay. So I'm going to do something we haven't done in a really long time. Okay. When you see this, I can't use a U-substitution, right? Because my U-sub has to be a 2x and I've still got another x hanging out. Okay. I can't use an arctangent because I don't have the derivative up in the top. Okay. So when that fails, we get out long division. All right, so we're going to take the top inside and the bottom goes out. We haven't done that in a long time, have we? It's been 2 years, probably, because we didn't touch it last year. It's fine. It's going to change it to make it so that we can integrate it. All right? So I'm going to divide. How many times does x squared go into 4x squared?
4 times.
4 times. I'm going to distribute that. So 4 times x squared is 4x squared. What's 4 times 9? 36. And what are we supposed to do to the signs? Change them. Good. So we didn't forget everything from math analysis, right? Remember, this goes over what's ever on the outside. So negative 36 over x squared plus 9. This is going to replace what's inside the integral symbol. So what I'm going to do is I'm now going to integrate 4 minus 36 over x squared plus 9. That we know how to do. Okay. All right, so I'm going to rewrite my integral before I actually try to integrate it. I'm going to take this, I'm going to split it into 2, but I'm going to take that 4 and put it out front. What's wrong, Josue?
How'd you get the negative 36 again?
I have to, you understand how I got the 4, right?
Yeah.
I multiplied 4 times 9, that gave me 36, and then the long division says now we subtract, so we just basically switch the signs. Okay? All right, and then this one here I'm going to write as 36, 1 over x squared plus 3 squared. Does it matter what order the a and the u are in?
Not really.
Not really, no. Okay? Doesn't really matter for arctangent. For the others, it makes more of a, you got to have it in a certain order. All right, let's try to integrate. So when I integrate 4 dx, what do we get? 4 what?
Plus c.
No. What's the integral of dx, guys?
X.
There you go. Okay. Minus, I'm going to keep the 36 out front. Okay, I will need you to look at your chart that should be in front of you. Which inverse trig do we have? It's arctangent again. It goes 1 over what? A, which was 3. Good. Arctangent of what? U over A, which gives me x over 3 plus c. This is a perfectly good answer. However, it is possible they may multiply that in there, right? And it's not distributed, it's just multiplied by the 1/3. So it's negative 36 times 1/3. Nope. Close.
Negative 13.
Nope.
12.
There you go. Of x over 3 plus c. So either one of these is a good answer. Okay?
They're so confident in 13.
All right. Everybody good with what we got there? All right. So we've seen a bunch of arctangents. Now we're going to see something else. Okay? So the way it sits, we can't integrate that one the way it looks. But I could split it into 2 fractions. So here's another technique of something we can do. We can split it up. So I'm going to split it into, I don't know why I have. So I'm going to split it into x over the square root of 4 minus x squared dx plus the integral of 3 over the square root of 4 minus x squared dx. Okay.
How do you know to do that?
How do I know to do that? I couldn't U-substitute it, right? So the only other thing I know to do with fractions is break them up with the same denominator and try that. Okay? The other thing sometimes we look at, it's not, but it's usually not, it was possibly multiplying by a conjugate, but we don't really have a good setup for a conjugate down there. Okay? All right. So if I look at this piece over here, okay, I probably set up for a U-substitution, aren't I?
Yeah.
So what do you think you're going to use as your U?
4 minus x.
Good. So du is equal to what?
2x.
Negative 2x. Good. I have the x. What are we missing?
The negative 2.
The negative 2. So I got to move the negative 2 over to the other side. All right. I'm going to do a bunch of stuff at once, so pay attention. Okay? So, this piece here, what am I subbing in for that little chunk right there? U. What power are we going to raise it to?
The negative 1/2.
So we'd raise it to the 1/2 for the square root, and then to bring it upstairs, we make it negative. Okay? All right. For the x dx, I am subbing in negative 1/2, which I already wrote down, du. While we're doing this, I might as well finish it, right? Go through this one, and then we'll deal with the other half. So negative 1/2, when I integrate u to the negative 1/2, what do we get? U to the 1/2 divided by 1/2 or multiplied by 2. So I really have negative square root. Let's see. What's going in this in the parentheses?
4 minus x.
Good. Okay. Let's deal with the other side here. The 3 is just going to be a 3 out in front, isn't it? Okay, so I'm going to write a little bit here. I probably wouldn't do this if I was just doing my homework, but we're doing notes. So I'm going to rewrite that as 2 squared minus x squared dx. So I want you to look at your inverse trig. Which one is that? Which one is it? You guys should be looking at the chart.
Arc sine.
Arc sine. Okay. So does arc sine have anything in front?
No.
No. So we just write arc sine. Again, there's your u. This is your, I'm sorry, I've got it backwards. This is a, right?
Yeah.
That's u. So arc sine of u over a. So what would I write down for this problem? Okay, remember you drop your squared. So x over 2. And then we always, when we integrate, we'll have to write what on the end?
Plus C.
Plus c. So plus 3. It's really this one here. Arc sine x over 2 plus c. So this would be our final answer. For some reason in my notes, we added limits to it. I don't know why. There may be some in the book that do limits, but you guys should be able to do that from there. Okay? All right. Let's take a look at example 5. Okay. Oh, I see what I did here. All right, I'm going to rewrite it. So I'm going to rewrite it as x squared over, I want to see if I can get it to fit one of our inverse trig patterns. So what's another name for 16?
4 squared.
4 squared. What would be another name for x to the 6th?
X cubed.
X cubed squared. Now, part of the rule for our arctangent, arcsine, arccosine, or arcsecant, is our derivative has to appear in the top. So think about what this is if I used a U-substitution here. So u equals x cubed. What's du equal?
3x.
Do you see the derivative in the top?
Yeah.
What's the only thing that I'm missing?
3.
The 3. So I have to move the 1/3 over. So I'm going to do a u sub embedded into the arc. Whatever. Okay, so let's put our u in. So I'm doing minus u squared. which is going to get confusing because we already had a u, huh? We have a u in the formula. For the x squared dx, I put in 1/3 du. All right, I'm dropping the 1/3 down. Look at your 3 choices. Which one is this going to be? Do we agree with arcsine? Okay, arcsine didn't have anything in front. Then it's got u over a. So I put in u. What's my a that I'm going to put in? 4. Instead of writing that u, what is u really in our problem? So I'm undoing my u substitution and putting my x cubed back in, and then we always write plus c. Alexis has plus c down. If nothing else, we can write plus c, right? All right. Make sure you have that one because the next one has something weird happen. All right. Okay. Let's talk about this one. So, kind of don't know what to do. I don't have a good pattern set up for an arctangent, okay? Because this isn't squared. So let's see what would happen if I started with a u substitution. So what would you pick as your u? I heard. Yeah, the entire denominator. 1 plus e to the x. Okay? If we were going to guess a u, that would be the u we would guess. So that means du would have to be what? Do we have e to the x? No. Okay? But we could get it in there. So here's how we're going to artificially create what we want. Okay? So I'm going to put an e to the x in. But if I add an e to the x, I also have to subtract an e to the x. So this is just one of those techniques that you got to see it a couple of times in order to know that it exists. Okay? So I added an e to the x and I subtracted an e to the x. Now, I'm going to split this up a little bit over, this is a common denominator, I'm going to split it into 2 fractions. So I've got 1 plus e to the x over 1 plus e to the x dx minus e to the x over 1 plus e to the x dx. So I took this piece and broke it off into the second integral. What's 1 plus e to the x over 1 plus e to the x? 1. When I integrate 1 dx, what do we get? X. Good. So I'm going to, but I've already set up the u substitution, haven't I? This is just going to be the u substitution piece over here. So we're going to integrate 1 over u. The e to the x dx is the du. So okay, good. Natural log of u. Instead of writing u down, what are we going to write? And then we're going to add c. So the trick, and it's not a trick, the key to that one, okay, is e to the x minus e to the negative x. All right, we ready for the next one? Okay. So, let's play with the u. Let's see if you guys can figure it out. I'm going to use this entire back thing as the u. So natural log of sine x. Okay. So du, what's the derivative of the natural log of sine x? Derivative natural log of anything is what?
1 over sine x times negative cosine.
What's the derivative of sine? Cosine. So my question to you is, do we have cosine over sine in our problem?
Yes.
Couldn't I redo that? Couldn't I rewrite that as cosine x over sine x, natural log of sine x dx? So this entire thing gets replaced with what? U. The cosine over sine x dx gets replaced with du, and I left way too much space. All right, so we add 1, we get u to the squared over 2 plus c, and instead of writing u, I'm going to write natural log of sine x squared. Be careful where you're putting your squared. It shouldn't be on an x. Okay, you need the parentheses. It's really squaring the log, not squaring the sine. What's wrong, Gab?
How'd you get cosine over sine x
Out of this? Look up at the window. This window over here. See the first window, second column, last sign.
Yeah.
Cotangent is this cosine over the sine.
Oh,
Okay? Math analysis, right? Our good old trig. Okay. We don't do cotangent that often, right? We do tangent, but more than we do cotangent. Josue, what's wrong?
Did you use chain rule?
I kind of used a reverse of. I used chain rule over here.
Yeah, right there.
Yeah, I used chain rule.
Okay.
Okay. All right, everybody good?
Wait, for the natural log of sine x squared, could you bring it down, make it 2 natural log of sine x, and cancel the 2?
You could. So did everybody hear what Kaylee said? We have a log property there that we could do. We could take this because of the log and bring it in front, couldn't we? 2 natural log. I didn't go that far when I wrote down my notes earlier, or a year before. So I could bring it down to this. Plus c, sine x plus c. Okay. All right, last one for today. Okay. Ideas. What do you think? What does your instinct tell you to do first? Not run.
Take that 2 at the end of the tan and put it in the front of the integral.
Can't do that.
Divide it.
U-substitution, though, I can do. Okay. So I can rewrite that as, let's see, I don't have the, or sorry, u is 2x. Du would then be what? 2 dx. Do I have the 2 hanging out outside anywhere?
No.
So I need to move that over. So du equals 1/2 du equals dx. So let's sub in. So now I've got the tangent squared of u. Instead of dx, I'm writing 1/2 du. All right, I want you to look at your integral table. So everybody's looking at the end. I want you to look for tangent squared. Does tangent squared exist? No. Tangent does. We can't just integrate that without another u sub.
Can you do tangent mu times tangent?
No. But what we could do is use a trig identity. So, okay, I want everybody looking up at the windows now. Look at your trig identities. Think Pythagorean.
Secant squared of u minus 1.
We can sub in secant squared u minus 1. Does everybody see where we got that from? So if you look, it's the middle window, the middle row of signs. It's the last sign in that middle row. Tangent squared u equals secant squared u minus 1. Is secant squared on our list of things we're allowed to integrate?
Yes.
Yes. Okay, so that's why I knew to do that. It's because the tangent squared didn't work. It wasn't on my list, but I know secant squared is. So I used the trig identity. You're going to see from here on in, through chapter 8, we're going to use a lot more of our trig identities than we did last year. Okay? So, 1/2. When we integrate secant squared, what do we get? Oh.
Secant times.
No, look at what it says on the chart. When we integrate secant squared, what do we get, guys?
Tangent.
Tangent. Instead of writing u, what are we going to write down?
2x.
2x minus, when we integrate 1, what do we get? X, or in this case u, but instead of u we're writing down 2x. Okay? And then we always write what at the end? Plus c. Could I distribute that 1/2 in? Yeah, so I'd end up with 1/2 tangent of 2x. What's 1/2 times 2x? Negative x plus c. So again, either one of those is probably a good answer. Okay, that's all that I have for you today. So you've got time to get started on this. Okay. So it is in haiku. Okay, I think. I put it there this morning, I thought. I did try to start a chapter 8 tab. It should be homework 37, should be the right number, right? Okay. So you're working through that. If you want to get stuff stamped, you can come and see me.